All right, we're back with another Ohio State test standard review. Today we're looking at standard 8.F.3, another continuation of our functions unit. So let's hop right in. A graph passes through the points 0, 0, 1, 2, and 2, 5. What statement about the graph is true? A, it is linear because the graph passes through the origin. B, it is not linear because the graph passes through the origin. C, it is linear because a straight line can pass through the given points. Or D, it is not linear because a straight line cannot pass through the given points. So here's the thing about linear functions, okay? It does not matter if your function passes through the origin when you're determining if it's linear or nonlinear, okay? When you're doing that, like any function, whether it's linear or nonlinear, can go through the origin, just like anything cannot. You could have, say, a parabola like this that passes through the origin, or even a parabola like this that passes through the origin. That doesn't make it linear, okay? And just like that, you can have lines that don't pass through the origin like this. That's a linear function. When you think of linear function, all you're thinking of is line. Break down linear. Line. Okay? So A and B are out immediately. So now we have to go through C and D. The key to a linear function is that your slope between any 2 points is consistent, meaning that if I take the slope of 0, 0 and 1, 2, and then I take the slope of 1, 2, and 2, 5, it should be the same. Okay? Now, let's talk about finding slope. Slope is y2 minus y1 over x2 minus x1. The change in y over the change in x, the rise over run, we've referred to it as so many different things. So let's take a look at our first set of points. 0, 0, x1, y1, 1, 2, x2, y2. So y2, in this case, would be 2. y1 would be 0. 2 minus 0. x2 would be 1. x1 would be 0. That gives us a slope of 2 over 1, or a slope of 2. Now let's compare that to the slope of another set of points. 1, 2, and 2, 5. And we'll calculate the slope again. We'll label our x1, y1, x2, y2. y2 in this case is 5. y1 is 2. Over. x2 is 2. x1 is 1. So that gives us 3 over 1, or 3. Does 3 match 2? No. So because our slope is not the same, it's not consistent, then it is non-linear. It would be sort of like a curve in a sense. So it is not linear because a straight line cannot pass through the given points. Because if you were to draw this, I'm going to borrow one of these graphs down here, right? 0, 0, 1, 2, and 2, 5. You can't draw a straight line that goes through all 3 of these points, right? You can draw one that goes through these points. You can draw the one that goes through these points. But you can't draw one that goes through all 3. That would be some sort of, like I said, curve. And that means that it's not linear. So it's D. Which graph represents a function that is linear? Okay. A function that is linear. So again, when you break down linear, you see line. Which one of these is a straight line? C. Done. Move on. 4 functions are shown. Which one is linear? Okay. So when we talk about linear functions, obviously if they give you a graph, you can just check to see if it's a straight line. Is D a straight line? No, it has a curve. D is out immediately. Okay? Then, if they give you an equation, there's two rules for a linear function. Two rules. Here we go. Rule 1. There can be no exponents on your variables. There can be no exponents on your variables. Rule 2. X and Y must be on opposite sides of the equal sign and not in a denominator. And that's not to say that they have to be on the opposite side at the very start. You can use algebra and our laws of equality, subtract x from both sides, what have you, to manipulate it so that it can get there. Okay? So A, our x has an exponent. So we x it out because that's bad. So now we're looking for the point that has the consistent slope because that's the only other thing we have. So I'm going to check the slope here. Okay? So between this x and this x, 0 minus negative 3, we're adding 3. 3 minus 0, we're adding 3. 1 minus negative 1 is adding 2. 1 minus negative 1 is adding 2. 3 minus 1 is adding 2. You see that we stay consistent. Our slope here would be 2 over 3. Our change in y over our change in x. Because it's consistent, that has to be our correct answer. Next question. Which graph represents y as a linear function of x? This is a tricky question, and I'll tell you why. Because you have to remember the definition of function. A function cannot have repeating x's. It cannot fail the vertical line test. So A is a straight line. B is a straight line. C is not. C is out. D is not. D is out. So you're between A and B. But the trick with B is that B is not a function because it fails the vertical line test. If you were to take a vertical line and you were to bring it over B, it fails because it's always touching. Here, it passes the vertical line test. So that's all good. That's all good. So it is A, not B. It has to be both linear and a function. Okay? Okay. Which table represents a linear function? So here we go. We're just going to try to quickly. You want to try to move through this quickly because actually rephrase. You want to take your time, right? You need to take your time to make sure that you're right. But if you can get through these quickly, because these problems, as you can tell, are a bit of a slog, okay? So if you can eliminate a choice quickly, that is to your advantage. So, A. Let's do our differences. 4 minus 3. 1, positive 1. 3 minus 2, positive 1. 2 minus 1, positive 1. 3 minus 1 is positive 2. 1 minus 3 is negative 2. Uh-oh. These don't match. So that's out. Okay. Next one. B. 1 minus 0, positive 1. 0 minus negative 1, positive 1. Negative 1 minus negative 2, positive 1. 4 minus 3, positive 1. 3 minus 2, positive 1. 2 minus 1, positive 1. Consistent, consistent, consistent. B. All right. Which table represents a nonlinear function? So last time we were looking for the table that had the consistent slope. Now we're looking for the nonlinear function, which means we're looking for the table that does not have a consistent slope. Same process though. 10 minus 4 is 6. 4 minus 1 is 3. 1 minus 1 is, 1 minus negative 1 is 2. 5 minus 3 is 2. 8 minus 5 is 3. 14 minus 8 is 6. Now, this may look nonlinear because it doesn't really look super consistent. These are always changing. These are always changing. However, if you calculate the slope by dividing your change in y over your change in x, 2 divided by 2 gives you a slope of 1. 3 divided by 3 gives you a slope of 1. 6 divided by 6 gives you a slope of 1. So the slope is always consistent. Therefore, it is linear. So let's go to our next choice. 9 minus 6 is positive 3. 6 minus 4 is positive 2. 4 minus 0 is positive 4. 27 minus 18 is positive 9. 18 minus 12 is positive 6. 12 minus 0 is positive 12. Now all of our numbers are different. So we need to do this again. We need to divide our change in y by our change in x. 9 divided by 3 is 3. 6 divided by 2 is 3. 12 divided by 4 is 3. Our slopes are consistent, so it's linear. Choice C. 11 minus 7 is 4. 7 minus 5 is 2. 5 minus 2 is 3. 21 minus negative 13. This is where it starts to get tricky because we have a lot of minuses and negatives. Negative 8. Negative 13 minus negative 9 is negative 4. And finally, negative 9 minus negative 3 would be negative 6. So now we check our divide, change in y over change in x. Negative 6 divided by 3 would be negative 2. Negative 4 divided by positive 2 would be negative 2. Negative 8 divided by 4 would be negative 2. So these are also consistent, so this is also linear. So now, by process of elimination, we should have D as the answer, but let's double check. 10 minus 8, that's positive 2. 8 minus 4, that's positive 4. 4 minus 2 is positive 2. 65 minus 101. 101 minus 65, other way around, as positive 36. 65 minus 17 is positive 48. And 17 minus 5 is positive 12. We check our slopes. 12 divided by 2 is 6. 48 divided by 4 is 12. Uh-oh, slopes don't match. Nonlinear. Like I said, those problems can take a bit, depending on which choice is the right one and all that. All right, select all the equations that represent a nonlinear function. So remember our two rules. You can't have any exponents, and x and y have to be on opposite sides of the equal sign, not in a denominator. So choice 1 has an exponent, so it's nonlinear. Choice 2, this is literally in y equals mx plus b already. This is fine. Choice 3, this has you adding x's. This is combining like terms. If you combined like terms, 2x plus x would be 3x plus 9, which is in y equals mx plus b. So that's fine. 4. 4 is the tricky one because it doesn't look like there's an exponent there. But remember your first step of equation solving. Remember we talked about don't call me after midnight? Distribute, combine like terms, move all variables to one side of the equation, undo your addition and subtraction on the same side of the variable, undo your multiplication and division on the same side of the variable. Okay. Your first step here is to distribute. X times 3x would make 3x squared. And x times 10 would make 10x. Uh-oh, now we have an exponent. That's it. Y equals x to the third plus 10. This is fine. There's no exponents. X and y are on opposite sides of the equal sign. X and y are not in denominators. Linear. So it's just these two choices. And remember, select all means more than one right answer. More than one right answer. More than one right answer. Okay. Which graph represents a linear function? So this is just like the other one we did. C is not a straight line. Bad. B is not a straight line. Bad. A fails the vertical line test. Bad. D, straight line that doesn't fail the vertical line test. D. All right. And that is the last question for this standard. So that's going to do it for this standard video. I hope this was helpful to you. I'll be back with another standard soon. Until then, good luck with your state test.